What?
Someone ran out in our.
Oh, the Croc used that for CS344. Hello, future viewers of the YouTube stream thing. Media team should cut this part out and skip to the part where we actually start the lesson. If this part is still here, then it's the unedited video, and sorry about that. Okay.
Do you know why I made the joke about pseudo touch junk? I saw that in one of our root accounts bash histories.
What?
Links to the slides are on the Linkedin website.
Okay.
We should also put them on the Facebook.
Do you have the head counts from the previous?
Just tell them to
Okay.
go to the website.
No. He's wrong. Nice of you to show us.
So, do we have the head counts from the previous two sections and then the head counts for these? And
I'm going to start counting once it starts.
Awesome. Thank you so much for doing that. Just wanted to make sure that was happening.
Were you up until like 6 this morning?
No, what's the IP address for the shell you created in?
And then you decided to grace us with your presence like 5 minutes before I even started. That's okay.
If you want to see the box talk, you go to the box talk. If you want to show it here, it's verbally connected to IRC, but
I just commented about. I'm going to have Emily do the IRC stuff, and I just told her you and Anthony and her just interject at any point. If you want to talk, that's fine. If you just want to sit out, that's fine too.
Yeah, I actually have literally no idea how to do this.
So that's fine.
I can try and ask a question.
Yeah, that works. Yeah, 2 minutes.
2 minutes.
I'm
Something like that.
running the control.
10 minutes.
10 minutes.
We're Anna's lesson 3. Don't worry about it.
But I have to come back on a River Valley.
I guess I shouldn't go after him if it's actually floating point. And possibly your next commentary. Okay. That's good. That's cool. So yeah, as your
Otherwise, I'll just write out.
oh yeah, asking questions. Asking questions is wonderful. Don't ask the one for 12 years yet. So, Rick, you going?
Yeah.
Okay, welcome back to the beginner track. Hello humans, could I ask you to please stop talking? We're going to start talking at you instead. It's going to be great. You're humans too. So, welcome back to the beginner track. This is the Linux Basics or Single System Fundamentals part. Now that you have a Linux installation accessible to you and someone, you have an idea of what the terminal is, we're going to show you a bunch of cool stuff that you can do at it. So, was anybody here not here for the last session? Do you have access to Linux somehow? Sweet, then we're good. So I'm now going to hand it over to Pono to take it away.
Hey, Pono, my name is Daniel. It's my IRC handle. I'm going to talk to you guys about Linux. All right, so we're going to cover that. So what's an operating system? So I think we covered this a little bit in the last talk. The operating system is the level of software that interacts with the hardware. So it's at a really low level. That's where the kernel is, and that's kind of where Linux comes into play. The Linux kernel is the part of the operating system that talks to the hardware, and the GNU user space utils are the things that you interact with on top of that. There's a bunch of different operating systems. Obviously, a bunch of you guys have OS X and Windows on. There's also one of my favorite, Plan 9. And you use different operating systems for different things. We use typically Linux or BSD for servers, and then desktops typically run Windows and OS X. And then phones run Android, but Android runs Linux, so way to go. Jordan covered this a little bit. Terminals are a sticky thing. Essentially, it's a text interface to interact with your operating system. As opposed to using a point-and-click interface, we're going to be interacting with text commands. So we're just going to be writing commands and then sending those directly through the operating system to process and do a thing. So shell commands. We might have done this a little bit. So does everybody have their... oh, can we fix that? I know one way to fix it.
Yeah. F11. And then.
How's that?
Nope, that's worse.
Yeah.
That's way worse.
These projectors are
Maybe I can. How's?
Oh, that'll do.
Is that good? Can people still read that?
Screen down.
Yeah.
Yes.
Also, these slides are. Yeah.
The slides are available on the website. I'll just assist you here. Okay.
There.
There we go.
So the slides are available here at slides. Is the wrong URL. Slides.osuosl.org. I'll type it in up here. It's in the search bar. You can see it here. And then you just go to Daycamp. Actually, I'll just do this right here. Slides.osuosl.org, and then we can go to.
You're way off the screen again. Anyway, so we go to Daycamp.
You can slide down to 99-Daycamp Intro Track Session 2, and you can follow along at home.
We could make it small again so that people can read. Yeah. Okay. That'll do.
All right. We're about at this weird slide. Cool. So does everybody have their, they've all SSH'd into their virtual machine?
So be at your command line and you can follow along.
Cool. So this is what I was talking about. So we've got a text interface to interact with the operating system. This is really good because if you don't have, if you're remotely connected, like we are in this case with SSH, we don't have to have graphics to interact with the operating system. We can just send text, and text is really easy to send. So we can use commands. So in this case, we're running the tree command, which should be installed. So somebody's going to tell me. Cool. All right.
Tree prefix your directory structure. The absolute basic commands that you need to know to get around instead of using your GUI file viewer are ls. This is what's in your current directory. CD, this changes directory. To CD down, like in a level, you say CD and then the name of the thing you want CD into. Now, if you want to go back up again, the parent directory is always named .. So if you go CD, if I'm in scripts and I CD space .. that'll take me up to code.
Yep. So every command line will have the name of the program. So in this case, tree or ls, as you guys have. And then it'll have options for flags. We'll cover that a little bit later. And then like an argument. So it's kind of like a function in math. Okay.
So,
cool. So invoking a script. So a script is basically just a local a local program. So it's like relative to where you are now. So in this case, if we ls-l, so that's going to list files with extra information. You can change the permissions on this file. +x means executable. So what that means is that all files on your disk have these flags set. Executable means you can actually run it. This isn't the case for all files, and you don't want this to be the case for all files. For instance, if you click on Windows, how many times have you went to download a file and that you went to download cat.gif and you got cat.exe.jpg or jpeg.exe? These are not files you want to run. These are suspicious files. So we don't want them to have the default permission to be executable because it could be malicious. So we need to explicitly state that we want the file to be executable, and then we can run that file. So this // notation means in the local directory, run the name of the file following this. So / here / the name of the file.
and remember what we talked about in the first session, anything that starts with a $sign, here we have it starting with a $sign, That's your prompt. That tells you type it in at the terminal. And then we have $ file name. That's meant to be a variable. That's just whatever file you want to run. Now, one note is that if you're on a clean virtual machine, you won't have any files in your home directory. So if you want to see what happens when you ls with various flags, type ls space dash whatever the flags are, space slash, and that'll show you the root where everything else, not slash, slash. No, not before. See the up arrow there, saved and retyping everything. So that shows you all of the different things available on your file system, who owns them, what their permissions are, and we will get into way more detail on files in a future talk with boot camp.
So now play along at home. These are 4 different ls commands. The first 2 will run the same. So these are the flags I was talking about. So these are options you can give to your program. So for instance, if you have a really old game on Windows that you want to run, you need to right-click it, properties, set like run in Windows 95 mode, because I like really old video games. In this case, we're using flags instead, so we can just call the program directly with the options that we want it to do. So by default, it's got a minimal set of options that are going to run. These times, we're explicitly setting these flags to get more options out of it.
Now, how do we find out what those options are and what are available to us?
There's this amazing program called man. What, any guesses on what man does? Manual. So man is a silly name, but we can look at the manual page for the man command. Oh, no way.
What? Oh, okay, we might have to talk about package manager.
Okay, so cool. So this is the command you guys are going to run, and it's not going to work on here, but you're going to run sudo yum install man.
And then enter, and it will ask you for a password. What you're doing will go. Okay. So if you are if you're on the virtual machine, it will be yum. If you are not on the virtual machine, because either you have your own Linux installation or your SSH to a shell, then
If it's on the shell should already have
shell
it.
should have man installed. Your local Linux installation really should have man installed. Only do this if man didn't work for you.
Question? Yes. Don't even read it. Just hit yes. No, I'm joking.
Read it.
So read it. So you should read it out loud. We can see what it says. Okay. So what?
If you really want it, it's going to take up this much space on your disk. This kind of takes back to the days when this space was a limited commodity.
Also, what it's also doing is, let's say man has dependencies. So man requires a library that we need. It's going to install the whole set of dependencies. So it's telling you everything that's going to be installed. Do you really want to do it? Yes. Yes, we do.
Question over there?
I didn't need the password.
Cool. That's good.
Yeah, question? Oh, so we'll talk a bit more
That's
about managers
That's okay.
later. But basically, for this operating system, in your case, CentOS, there's a bunch of wonderful maintainer people who maintain a list of packages that will just work on CentOS. And it has some metadata associated that helps you get the right version of that package for your version. The command yum invokes your package manager, and then it goes out to a predefined place on the internet. It's probably defined in a sources.list or similar. And it goes out to a mirror, and then it downloads the correct version of man in this case, and then it comes and installs it. So it's coming from this random site on the internet that the people who released your operating system have made sure will only have packages that are reasonably okay to install.
So we're jumping forward like an hour talking about package management, but it's fun to do more advanced things.
It's okay. We try to. So,
All right, so we're going to move on from
we're
here.
gonna move on. We got
Anthony,
another
do you
question
wanna-
out there. Okay.
Okay.
So
All right.
if we could bring it back together, we'll have a few minutes in a bit to troubleshoot any problems that you might have had. But could I ask you to come back with us for now, Justin?
So these were 4 commands. So these first 2 executed the same. So notice that we're doing the flags -A and -L in this case. And then in the second one, we're doing just -AL. Flags will, by default, want to be singular. But if you have a whole list of them, most commands will accept the list as a single hyphen. This is convenient, but it gets into another issue of what happens if your flags are multiple letters long themselves. So these last two commands, -si, this is going to operate in a similar way to ls-al. Those are two separate flags that are concatenated with a single hyphen. This second one, --, means that the SI is in and of itself its own flag. I think in this case it refers to like the scientific indexing. It's going to give your numbers in scientific notation.
With this, often there will be redundant flags like -a and --all will do the exact same thing.
Yep.
So, quick food for thought. Why is it better to pass the argument in when you're invoking the script than to just ask for them interactively? Thoughts on that?
Non-rhetorical question.
Non-rhetorical question.
What would you use?
Huh?
What would you fetch?
So the two dashes, so customarily flags are a single character, but there are some flags, let's say you have more than 26 flags that your program operates on, you'll need to go into double digits then for letter combinations.
And sometimes it's easier to understand what command meant if you actually spell the flags out. So you can do the long version of a flag, or maybe the long version takes a particular argument. Double dash says read until the next space, and that's the name of the flag.
There's some common practice for Unix utilities, but a lot of it varies program to program. So anybody have a thought on why we want to pass flags rather than have it ask us every single time we ran the program? Yeah, way quicker, right?
Easier to automate, easier to run it on somebody else's or on a computer that's a long ways away and just have it run in the background. Like if you've got a task that runs every hour, you don't want to wake up in the middle of the night and type things in.
So like Emily was mentioning, we've got a couple special file paths. So there's always the absolute file paths. So in OS X actually uses the same disk notation that Linux does. Windows uses a different one. So with Linux, we have slash being the root, so ls/. So slash on an equivalent Windows machine is like the C drive. So like it would be something like that. That's not going to work because we're not.
It would be dir because there's no ls.
Sure. Still not a command. And then on OS X, it uses a very, very similar way of doing it. It uses the slash prefix for the root directory, and then it descends into users and that. So dot is the current directory. So ls and ls dot will be equivalent. ls dot dot. ls dot dot is going to list one level higher. So imagine descending into rooms.
So you can see it.
Oh, sorry.
It's okay. The plus,
Plus.
that thing. We'll shrink it a bit.
Just slide it. This one.
Yeah, now it's fine.
Yep. There we go. Now they can see the left-hand side. And then, what do I remember from? So,
don't worry about it.
fun. What he's doing right here is he's setting environment variables. One of the things that your shell has for you is a bunch of just variables that are set. PS1 is your prompt. That's everything up to the $sign. And he was doing prompt flag magic, which you can get from the man pages to change what was in the prompt there. And do you have a question?
Oh yeah, in the previous you had
The commands?
Yeah. It was highlighted green.
It was highlighted
Oh,
green.
the prompt was green.
Oh, yeah,
Because you had
for fanciness. Just to make it easier to differentiate. The typical prompt is user at host and then your directory. I'm shortening that just so that it fits on screen for us right now.
Oh, no,
So,
that's right. Ending your LS.
Oh,
Oh, yeah.
okay, cool. Yeah, let's talk about that.
Alias is something with color. There's a flag for listing with the directories one color and files another color and symbolic links another color. It just makes it easier to visually tell what's going on.
So ls. So ls here, and we see that there's blue and white. So this differentiation is for files and directories. When we ls the slash, we see that there's dark blue, light blue, and green. The light blue is something you shouldn't look at. It's magic. The blue is still directory, and then the green is executable. So that means that, you remember how on one of the slides we had a chmod plus x, we were making something executable. So this directory is executable. So the things to set.
We have a question up there. So ls will by default, or the question is, why are the results for ls and ls slash different? Because ls will by default list whatever directory you're in. So you pwd real quick. pwd is present working directory. So right now we're in home OSU/OSL. So when we ls in home OSU/OSL, or we do that explicitly, it's the exact same place. Now, if you don't want to list where you are, but you want to list some other part of the system, like an ls slash, then it'll list that part of the system instead. You cd up to slash and then do a bare ls.
So I moved to the root, and then when I ls, it defaults to listing the current working directory. ls dot is the same thing, and ls slash is the same thing.
Because if you pwd here, for present working directory, it'll say we're in slash right now. So the thing after ls, unless it starts with a hyphen, is the name of the place that you're listing the contents of. And unless you specify a place, it will assume that you want the place where you are right now. Does that answer your question? Cool. Let's go back to the slides.
Okay, so the only other one that we missed was tilde. So let's say I cd to documents, pwd. So this is where I am. And let's say I want to return to my home directory. I have a couple options here. I can go up. I'm going to go back to the documents. I can cd directory, or I can cd to tilde. So tilde is like ... It's a relative, or it's a. It's not relative. That was wrong.
Typing out the path to your home directory, because you don't always want time, or the tilde is the path to your home directory, and every time your shell sees a tilde, it will put that in. So, so this is helpful if you, because most of your stuff is assumed to be at that in your home directory, so it just makes it easier to get to your various files.
Keep going.
Okay. Okay, we just did that. File paths, special characters. As you've noticed, we've got things like dot and like tilde that are, that XKCD is completely invisible, just the same. We did put the XKCD and that'll make it big. Oh, that's very good. Right. Can we go back to the slide?
Yep.
So there are a variety of special characters. The ones that you should know about. You will probably discover special characters. Rather than just memorizing them all, you'll try to use them in a file name or in an argument that you're passing to a program, and it won't work. And your shell will do something weird, and you'll be like, what just happened? You'll look at what you typed, and you'll go, oh, that might be a special character. So, like, bang, the exclamation point refers to a previous command that you typed. Using a backslash will allow you to put in just a literal character. If you have one of them, let's say, in a file name, like escaping spaces in file names that we talked about earlier. Another important one, the pound sign, which please don't call it a hashtag because that makes people who are used to IRC and Linux kind of sad. So pound sign or octoport means a comment, means if you've done programming before, everything, the rest of this line is just going to be disregarded by the shell. So this is super useful when you're writing scripts and you're like, why did I do it that way? You can leave little notes to your future self or to whichever other person has to use your script in the future, which is probably going to be you. Be kind to yourself and explain what you're doing, because 6 months later, you're going to be like, what on earth was I thinking? Anyways, so the question mark, the splat, or asterisk capital A, matches is a wildcard for what's called shell flopping. Now, there are two ways or shell gloving is a way of matching several files that apply to a particular pattern that occurs in their name. We're not going to go into detail on that right now. Regular expressions are another way of matching a bunch of files. Gloving and regex are subtly different. That's most of what you need to know about them for now. You can we have a variety of resources on the details of them that you can read later. And the ampersands, double ampersand, you want to do two commands, but you only want to do the second one if the first one succeeded. So you do the first command, double ampersand, second command. And also, if you end the command with an ampersand, that backgrounds the process. I'll probably mention that when I'm talking about IRC. But, go ahead.
So typing less, this is a really neat trick. What you can do is, I think tab completion might have been mentioned in the last lecture.
I talked about tab completion, talked briefly about reverse.
So the other one that we have is Control R. So right now I'm going to press Control R. It's going to say this reverse iSearch, and then I can type something and it'll match previous commands that I've entered. So I've done a lot of LSs, so we can look for that one surely. If I hit Control R again, it'll look for the previous one before that, et cetera, et cetera.
And tab completion, remember your tab completion, tab key is your best friend.
So this is a really interesting one. You will need to know this. You will mess something up. We all do. Control C is the default kill behavior. So what that'll do is whatever current process you're working in, Control C will end it. It will save your life. It's not copy, right? So
Control Shift C is sometimes copy depending on your terminal setting.
yeah, so Control C should look something like that. It kind of shows this caret and then a capital C.
Ping something. Ping Google. And oh no, now there's stuff all over my screen.
And
Get me out of here.
I'm hitting enter and it's not ending, and I'm typing exit and I'm typing quit, and oh God, what's happening? So you hit Control C and it can end. Control D is a similar thing. It'll exit your shell if there's nothing there.
Or if you're in an interpreter like Python, that's in the end file character.
So if I do Control C, but Control D will exit my terminal.
I noticed he has one fewer tabs there.
This might be useful. Q or :Q is one common notation for quitting programs. So Vim is a text editor, and let's say I try to quit. Oh God, it's recording. Escape, and then :Q, and then :Q bang.
See how the error messages help you out? They're like, you can't just :Q, but you might have meant :Q exclamation point. So, and then go back to slide.
You had something?
Meta X, Meta C, Meta X. I don't know.
So it's like Control X, Control C, Control S.
Yeah.
A fun one is if it's kind of like busy. If you want to clear it, you can do Control L, and that will just kind of clear the screen. You can also manually type clear, enter, and that'll clear the screen. But I use that a lot when I want to see what a command is. I would not have all that extra, stuff from previous commands show.
Because we're all very clean people that like a pristine working terminal.
So basically, if you need to get out of somewhere, Control C, Control D, :Q, escape, 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 :Q, and you're probably out unless you found yourself in Emacs. If you're in Emacs, then I'm so sorry.
Control X, C.
Control X, Control
C.
C. Yeah, we'll get you out of Emacs.
All right, so we resolved that tree isn't installed, but how would you list all of the files in /temp? So you should go to your terminal right now and tell me what files are in the /tmp directory. Also tell me how to do it. I don't know. It's a homework question. I'm just getting them to do it for me.
Wait.
This is putting temp. That's how you spell temp.
Who does that say? Also, bonus points, whoever tells me what user you're currently logged in as. You don't count. All right, so anybody have an answer? Is there anything in /temp? Yes, no? Griffin, give me an answer. Okay. You have to try. Well, there's a couple miscellaneous files, we'll say.
We've got ice units, a bunch of stuff. So like, let's go back here though. So if you see this on your screen after running a command, you can tell me a bunch of things. Just shout it out. What user am I logged in as? Exactly, as test, and you can tell that because it's at the start of the prompt as the default PS1 photo data center. So what command did I just run? And what directory was I in? What directory would you assume I was in when I ran that command? I was in my home directory because the path to where I am is that tilde, and it's confirmed because doc is the current directory and the tree shows what's in it. I've got stuff like documents, pictures, that kind of thing.
So documents would be a good bet.
Indicative of a user.
And then the way we can tell that it's not documents is at the same level of this tree is another directory. So that means they have the same precedence in the tree.
A tree will usually start with doc unless you get special flag. Anyway,
More about man pages, read them lots.
yes, use, no, so important thing for man pages is if you go back to that slide, you want to search for a word in a man page, / whatever string of characters you want to find, and then you hit the end key to go to the next match, or shift end to go to the previous match.
So I'm hitting / and then help. And you'll see that it highlights the matched help right here.
And then hit end, and the next time the string HELP appears in your man page.
And then N will go backwards to the previously matched one. And then Q quits out of that.
So generally, I mean, a Google search is a pretty easy way to find examples. Man pages sometimes do have examples at the bottom of the man page, but a Google search, when I first started, Google search was way good.
So here's a neat website that you can check out. It's called Explain Shell. Is that? Yeah, it's totally digital. So I can type the name of a command and then a flag, and it will straight up tell me what it does. So this is another good reference.
Okay, we're half an hour in. Hit F5 to get back to the slides we were on. There we go. And if the program doesn't have a man page, sometimes casting -8 or double dash will get you the equivalent of a man page. Yeah, Google's your friend. That's the previous slide. So,
Go ahead.
okay, asking for help. It is okay to ask for help. It is good to ask for help. It is important to ask for help. There are not stupid questions for the first like 5 times that you ask a thing. And if you realize that you've asked it 5 times and haven't written it down somewhere, then we're going to start getting a little bit like encouraging you to write it down somewhere and look it up next time you need to know that. But there are not stupid questions. We are here to help you learn. So the good way of getting help when you ask for help, there's a right way and a wrong way. Wrong way, hey guys, it's broken. Right way, hey, I'm trying to do this thing. I've tried this because such and such a resource said that it would work. And yeah, I'm getting this error instead. Could you help me figure out what I'm doing wrong? Identify, make sure that you understand what you want to have happen, what actually happens instead. Google that problem, Google any error messages you get, skim the manuals of each component of what's going on, identify a friend or mentor or channel that could help, and then when you have reason to suspect that they're not too busy right now, give them a quick synopsis of what should happen, what you did, what happened instead, and mention what possibilities you've ruled out by searching, and then they will be amazed at how good at asking questions you are. Seriously. IRC channels especially are so accustomed to people coming in and going, it's broken, it won't work, and then having to drag all that information out of them, like pulling teeth, that they will be delighted to help you when you make it easy for them. So it's really a balance between trying not to waste the expert's time, like by looking in the docs and stuff first, but do build your expertise. It's worth it for them to invest some time in you so you can get better and help more newbies in turn. Especially good if you're working on an open source project to go to their docs, look in the docs where you think you should find a given thing, and be like, hey, I searched in your docs for such and such a keyword and didn't find anything. Could I help you fix your docs so that the next person who has this problem doesn't have to bug you? Then they will love you forever.
These are some things. We're going to skip that. Users. So here's some cool commands. So you should be able to run all 4 of these commands. These should give you output. So what are users? Users are users on your system. They're people, they're accounts. They have usually passwords in a shell set. These are the things that allow you to interact with the system. So when you're logged in, you are by default in a user account, whether it's the Vagrant account, the test account, your username account, whatever it is. So it's important to know who you are on a system because that user corresponds with a certain set of privileges. This includes read-write access to the file system. You're only allowed to look in your own home directory. I can't look at your home directory. By default, that's a good idea. The root user is the admin user. I think Windows used to have a thing that was an admin user. Now I think they just do a password for admin accounts. I don't know how it works on OS X, but root is the admin account. And that is the super user on the system. They have all privileges. So that's a important user account to keep secret.
It means that if you run a script as root, such as by going sudo, and it was trying to break stuff, it will be able to break stuff because it's assumed that the super user knows what they're doing. Don't let someone who doesn't know what they're doing, or don't let a program who doesn't know what it's doing be the super user, or it would break stuff really bad. This doesn't matter in your virtual machines because you can just blow it away and make a new one really trivially. But on a real server, it's very important to restrict root to only the people who absolutely need it.
So there's other types of users. There are process and system users. So this is kind of an idea that it may not be a real human, but it's a process and you want to be able to contain all of their privileges into a specific account. So your web server doesn't need to look at your home directory. So the web server can have its own user and its own set of permissions so that you can do this kind of privilege separation.
So the web server does need to be able to read the website, but it doesn't need to be able to execute code on the system necessarily. That helps you stay secure.
So these are features of users. You have a name, you have a UID. There's a numerical value corresponding. It's easier to store a number than it is to store a string on a computer. A group, by default, your user group is the same as your username. A shell, so we used bash in our example, but there are many, many different kinds of shell. One of the neatest is no login. That means that they don't have a default shell. Passwords and home directories. So not having a password, how would you log in as a user? It's kind of an interesting idea, but there are various ways of authenticating without a password. For instance, I think Android can take a picture of your face, and if you look enough like yourself, it'll let you into your phone. You can also do biometrics. There's other forms like private keys that can authenticate you so that you can prove who you are. And then, oh, go ahead.
I was going to say groups are pretty important because they allow you to say, hey, all of the users that fit this criterion, all of these particular users get those privileges. And that's very useful when you're actually administrating servers to say you can't do one.
So managing users, so these are commands.
Add user. Okay, so maybe we don't have add user, but.
Oh.
Okay, so all you need to know about that right now is that password file does not actually contain passwords. It contains the, we have a whoopsie user, okay.
Whoopsie is it logs errors.
Okay, it contains username, what's the X? And then has UID, groups, has the home dir, has their shell, and you notice that there are way more users on your system than there are people. I mean, there's just you on your favorite ones. But each thing, like pulses for audio, SSHD is for secure shell, which is a way of logging in. There's 36 users on this box, even though there's only one person who uses the OSL. There are commands out there for adding and removing users. Yes, but huh? Oh, cat stands for concatenate, and that just prints the contents of a file out to your terminal.
Great way to look it up. Man-cat. Concatenate files and print to standard output. Standard output will be kind of your terminal where you run it from. So it's the way to look into a file. It just dumps the contents of a file to your screen.
Yep, you can give it a bunch of different options. So there's user add versus add user. Difference is that user add just creates that user add user on systems that have it. creates like a folder for them and sets their shell, and there's this folder called Etsy Skell. When someone says Etsy, they don't mean that website where you buy tracks, they mean /etc, etc. We'll get into that when we talk about file systems. It basically adds all of the things that they expect that the user is probably going to need with add user. Versus user add is just the old school one. You get to add all of those things that your user is going to need, like making a home directory for them, setting the permissions on their home directory so they can actually do things in it, and so forth. You get to do that by hand. And then the password command changes passwords by default for the current user, or if you're a super user with those privileges, you can say password and then username, and that'll change their password. If you use add user, you will be asked for geckos. This is a very old system, General Electric Comprehensive Operating System data. So that tells you how old this is. It takes full name, office number and building, office phone, what room they're in, all the stuff. That data is where a program can read it and find out the full name of the user that's running it, if it has the right permissions. And that's how, like, your IRC client can fill in your name if you run IRC on an engineering server. Because on the engineering servers, they know they have your full name associated with your user ID. There's more commands that go with that. CHFN changes the geckos information. Finger tells you about a person. So you will see, like, finger username in examples. That just means tell me more about them. Yeah?
If I'm not a super user, can I add another user?
If you're not a super user, you cannot add another user on the system. That's not a default privilege of most users. Because if you could do that, then theoretically you could make a super user and then you could assume that account.
If you would need the ability to sudo. It's conceivable that you could configure a system such that a script that adds users is available to normal users. I'm not sure why you would do that, but it could be done. But it would not, it doesn't work that way out of the box.
The security implications are not good. So typically we restrict that for a super user. Passwords, secret information. These store a hash. A hash is a hard to reverse function. So it takes in a password, does a hard to reverse function on it, so it can store it on disk, but it can't be read off. So I can't just type in the hash of this password and log in and assume the identity of another user.
So if you give me a hash, I can tell you whether a password matches that hash. If you give me a password and a hash, by hashing the password and seeing if the two hashes match. If you give me a hash, I cannot tell you what password was hashed to get it. MicroSelect teaches a cryptography course here. If you're in the computer science department and you want to know more about that kind of security stuff.
So we can come back to this root super user idea. This is a good time. So root is the admin user. So he has UID 0, very important guy. UIDs increase over time as more users are added to the system. So 0 must be the most important because we count it from there. Sudo is a switch user do. So I want to assume the identity of another user and then run a command as them. Typically, this is done for the admin or done as the admin. So you want to sudo assume the root user's account and then execute a command. So in the case of adding a new user, I can sudo user add blah. So as my user, I don't have the permissions. I can assume the root user's identity, assuming I have the permissions in place to do that, and then I can execute a command as them. This doesn't just work for the root user. You can assume another user's identity. This might be useful for debugging permissions problems or things like this. And here's a cute comment. How are they?
What are the initial privileges granted?
For a user or for root? Very, very little. You can write files to your home directory.
You not by default you can't, because if you use user add, you don't have a home directory yet. A super user has to come in and set your permissions so that you own your home directory so that you can do things in it. You're basically a regular user on a fully secured system can't do much. They can do things in places where they own it or that are set so that everyone on the system is able to read or write there. There are a few locations on the system that have it so that everyone can read and write.
Yep.
Are there still restrictions to be sudo as root?
You don't need sudo if you're root.
If you're running user.
So if you're restrictions like if you have sudo, then you can do everything with root.
Sudoers can be restricted to only certain commands. Most of the time, especially in today's documentation, we're going to assume that if you can sudo, you can sudo to root. And therefore, you have access to all functions.
One thing to note, when you sudo up to do things as root, it will prompt you for a password. This password is the one that goes to your account, not to the root account. Because your username has been added to a file somewhere that tells the computer, hey, this person's allowed to sudo.
So one nice thing that you can do with sudo is you can restrict the privilege set. So by default, it's not. By default, you can run anything as root. But let's say I have a user that's the web developer on my server. I want to give them the rights to restart the web server process, but they're not the web server user. So I can give them the sudo access to restart the web server process, but nothing else. So that's a use case where you don't want to assign full root privileges, but you still want to allow somebody to assume the identity of another user. So this is kind of what we described. SU is for switch user. This will literally switch you to another user. Sudo runs one command or one series of commands as another user.
And I'm going to read this XKCD because I doubt you can read it from the back of the room. It says, so Rob M at home box, sudo su, password. And then you try to, you put this password in. Rob M is not in the sudoers file. This incident will be reported. Hey, so who does sudo report these incidents to? You know, I've never checked. And back on this list. So actually, it writes them to a log somewhere, and if the system administrator is watching that log or has a script that's watching that log, they count how many times somebody occurs in it, how frequently, and then they can do something based on that information.
One of the oddities of the sudoers file is that root is not in the sudoers file. So if you try to sudo as root, it'll tell you that you do not have the permissions to do such. This is kind of funny because root has permissions anyways.
So if you're managing users, you get permissions errors. First thing that you're going to want to do is list the files with their permissions, ls-l, and we'll tell you whether they own the files.
So I ls-l on /etc, which is where the configuration files are. So
root owns all the stuff that you. So somebody's trying to do something. A lot of these are. We're not going to go in flags in much detail today. So we've got so much to cover. But the first three are when you connect to ls-l, you get a bunch of magic numbers here. First one tells you what kind of thing it is. Is it a directory, like with the ones that start with D, or is it a regular file, like starts with dash? The first three are the permissions that the user who owns it has. R if they can write it, or a dash if they can't write it. W, or R if they can read, dash if they can't read. W if they can write, dash if they can't write. X if they can execute, dash if they can't execute. Now the next three are the permissions for the group. So it's owned by the root user and group as a group. You can have a different user and group own thing. Like I can have root own it, but the Apache group be the group for it. That's what the group can do. Read, can't write because there's a dash there, can't execute because there's a dash there. And then the final one is everybody else who's not that user or group. So for this file, Z command, everybody else can read it, everybody else can't write to it, everybody else can't execute it. Now for this xul ext directory, everybody else can execute that particular directory and can read it but cannot write it. So those we will go into much more detail on later, but those flags and you modify the flags with chmod, change mod, are what dictate what can and can't be done with a given file. We showed you ch mod plus x for executing script earlier. Question? The script. Okay.
So groups, we talked about this a little bit. It's very analogous to the way you treat users. There's user or group add. User mod will change the groups of a user. Group mod will change the properties of a group. And then you can see that the etc group file exists in a similar way to etc password.
Okay. And then that's what we were about before. So it's of the format group name, colon, then the password or placeholder. None of these guys actually have a password set because they're all the system stuff. Wouldn't need a password for anything. So they have X as placeholder, and then the group ID, and then if there are more people in the group, they're added in a comma separated lists with those spaces after that. So you want to do that? How are we doing on time? We're at slide 23 of 50 something.
I cut some. We've got time.
Okay, so We've got time.
So,
You got a question up there?
good question. Man, who am I?
Well,
Then we go to the end.
there's a command called groups. Just type groups. It'll show you the groups of your current user, or you can pass it. So like groups, some user will tell you what groups that user are in.
So we're in our own group, the admin group, the CD-ROM group. That's outdated. The sudo group, the dip group, plug dev, LP admin. LP admin's for printing, and Samba shares for looking at Windows files.
So and do like or I think it's just sorry, groups and then user. That's what we do. So you see like where users in the group.
Huh? Whoopsie. So this was a system user, and so you can see that they're not in any others. And ID is a little bit more specific. It'll tell you even the GID.
Any other questions? Yep. Nope. Okay.
So everybody has sudo privileges. So why don't you go ahead and add another user to your system?
If you're SSH to
Oh yeah, you will not be able to do that.
if you're SSH to somewhere that you probably don't have sudo, this is good. If you had sudo on a shared host, then you will be able to get into other people's personal files. And while you might think this is fun, having them in your personal files would not be fun. So look over the shoulder of someone who has a local virtual machine if you're in that. If you are SSH to somewhere else.
So do that for a second while I try to fix the shell that I broke.
So could you please go back to the slide so we can freeze the projector? Anthony, could you hit the freeze buttons on
On the tab.
at least one of them? And then Tony can do so.
I'm done.
Oh,
I knew the command. All along I know.
One of them?
that works. So
They're both frozen.
now you can do whatever you want. So try to create a user on your system for yourself using whatever handle you want to go by. Could be your engineering handle, could be your first name, can be whatever you want. Just couldn't have special characters in it.
How many people weren't able to install the manual command?
And if you're having problems installing man, then we will help you with that too.
Turns out first thing you need to do is reboot your VM, and that fixes the DNS problem you have. Yeah. I don't know what that.
Some people didn't have some.
So
Help conference didn't
to
have
reboot
network
your VM,
access, so
vagrant halt on whatever command line you started it from, and then vagrant
there's also restarting.
vagrant restart, probably. Man vagrant?
Is Vagrant on here?
Not on here. Also,
Yeah, that would help.
I thought it was D, but D is date. Why would you ever want to show the date in your prompt?
I don't know, but I time in my prompt because it makes
Time's nice, but date? Like,
because you rarely use the system.
I could be. I guess.
Or because you just really wish you could get a date.
Just got to be around them.
Yep.
D for date and not directory, though. Really, Unix? Really?
Unix is special.
What is the?
I don't know. I'm just running PWD every single time.
How many slides are we down to? Because I anticipate that IRC setup time will be pretty successful.
23. How do I? Is there a way to like zoom out?
Go up to the other one. There we go. And then I'm just gonna.
So the second thing, how are we supposed to tell people to do that?
I don't know. People can
Because we
figure
have
it
to
out.
like edit
That's
the
just wrong.
SEC file.
I just like that whatever box Gordon pulled in didn't have a man on it.
Yeah.
Like, that's why you don't use CentOS.
We're down to
CentOS is
46
so dumb.
slides.
So we're halfway
46
done.
slides, so
Perfect.
we're halfway done.
Minimal.
Yeah, you did. I straight up said we should prepare a
should
box.
And Jordan said not. Okay,
Yeah.
we're fighting in front of the microphone right now. They should cut this part. But
Yeah, you should cut this part. Whoever's editing
yeah,
this video probably
hi
me.
there, Elsie, or like Pono, I guess. Hi there, person editing the video. We're all just like derping around right now, so this part does not need to be in the final copy. Easter egg for anyone who watches on YouTube. See if it's still streaming. Oh my gosh. Success.
That's creamy. Creamy. Using that for a while. There you go. The guy Sean's talking to.
Oh, cool.
That's creamy.
Yeah.
To install software. Yeah. Sudo yum install, and then the name of the package.
So you need how would you get that?
I mean, you can change your own. Otherwise, you want to change different.
Yeah. So you know how see all the oh, one more.
Okay, yeah.
Come on. Yeah, there we go. So you see at the end of your next to it says so that signifies so the root user doesn't even sudo because it's already done. And that was the thing that I was mentioning is that root can't sudo.
You don't have to call it up.
Okay. Where did you so you run it down.
Yeah, no, I see that.
So now, so we need to see what the thing is possible. So we can find that. Missing one.
Yeah, see, change the okay, so right now you want sudo.
I'm going to give you a general. So now you need to be
So what I would do so that yeah, so whatever it automatically carries it. So every user pretty much yes, those kind of commands can do user mod. All you need is so there's nothing there. But now you plug it in. It's going to install this is where the download install something here and something so you can look at information.
Okay, I know that this hasn't been enough time to get everything completely debugged, but I'd like to bring it back at the moment. Guys, can I interrupt, please? I know that we haven't had enough time to debug everything, but I'd like to bring it back now to make sure that we have enough time to get through all the rest of our content. We'll be around in the break after this lesson to do some more debugging. And there are a few things that I noticed when going around helping people, and the other people who were helping may have comments on these as well. Just to clarify on your vagrant boxes, you only need to do the vagrant init and that part once. And once you have that box created with vagrant init, then in the same directory as you have your vagrant file, you use vagrant up to start the machine or vagrant halt to stop it. So the equivalent of rebooting is vagrant halt and then vagrant up. You can't run vagrant init again with the same name because you've already got a box by that name. And turns out that add user is available on the image that we gave you. Add user solves a lot of your problems for you. And does anybody have like conceptual questions about what we just did?
Cool.
More or less. So I know we didn't take enough time to get everything completely troubleshot. There will be more time at the end, but I just want to make sure we get through.
All right, so next up we have files. So files are everything. On Unix, one of the core designs of the operating system is that everything is a file, so you can interact with things as such. There are, but we'll pretend there aren't. very special files. So the basic idea here is that anything that's anything that I can see with ls, I can interact with like a normal file. So files have owner's permissions, inode, size, and file name. So Emily went over this a little bit. So this is maybe the size. That is not the size.
I think I know. Yeah, your LS with PACI.
Yeah.
So the inode is a magic number that refers to where the file lives. We're not going to go into detail on this right now. You'll talk a whole bunch about them if you take CS344. Long story short, a directory is actually a mapping of file names to inodes. So when you move a file around the same device, it needs to move really quickly because the file itself isn't actually moved. You just change the place where you're pointing at the file from. That's confusing and you don't need to understand it in detail for what we're doing today.
Next up, so file extensions. So this is a really neat command, file. So on Windows, you know, and I think OS X does this too, when you're in your file browser and you see a bunch of files listed, it'll show an icon for that file. And depending on what type of file that is, it'll change the picture for that. So the command line obviously doesn't have icons, so instead what we use is file. Because the suffix of the file is not necessarily descriptive of what type of file it is. So we can use file on any file, and it will give us metadata about that.
So yeah, the file itself actually contains data about what type it is. So you could have like picture.text that's actually a JPEG image. You can have like thing.jpg that's actually an animated GIF. The file extension is there for a variety of reasons, but telling the operating system what kind of file it is not one of those reasons.
Okay, so I just downloaded a file, xkcd, and I'm going to change the name to xkcd.txt instead of png. But
So the mv is a move command. You can also use it to rename files.
But when we run file on it, we actually see that changing the suffix for it didn't change the metadata about the file at all. So in fact, the suffix of a file, the .extension format, is just for humans. The computer doesn't care about it at all.
Well, and it's for scripts that we write. Like, find all the text files in the directory. Let's go by things that end in .text. That would make sense, right? So,
LSL we covered.
we kind of covered it. Let's go over it again because it's important to understand what the permission bits do. So, the first bit, what's the first bit telling? The type, exactly. There are a variety of types. The ones we care about right now are D for directory or dash for regular file. The next 3 bits, what do those tell me? Whose permissions are they for? Exactly. So this pictures folder, can the user write to the pictures folder? Yes. Can the user execute the pictures folder? This file.text, can the user execute it? Perfect. So the next 3 bits, what are they for? Yup. So in documents, can the group that owns it read it? Which group owns it? Yes, exactly, test. And I know that because user group, so it's the second one there. The next 3 are the rest of the world, other. So if I'm not in this user and not in this group, can I write to file.text? Yep. What can I do with file.text if I'm not in the user or the group? Precisely. You get it. Or you can answer questions on it. That's an important step forward getting it. So let's keep going. So this has a lot of detail on change log. We're not going to cover all the detail, but it is here in the slides for you when you want to look back on it. So there are 3 different ways of expressing a given permission. You can do it the letters way, you can do it a binary way, or you can do it an octal way. So in
So each of the read, write, and execute bits are just that. They're bits. They're zeros or ones. So they're either a true or false value. So each of these corresponds, they're exactly the same. So you see in the binary representation, it matches up exactly with whether the letter exists in that slot or not. So in the 000 case, it's nothing. So zeros represent that.
And if you have all the flags, you get 111. If you have the first 2 but not the last one, you get 110.
And the octal represents just the sum of those values. Those will be unique.
1, 2, 4, because it's in binary. So we care about octal because sometimes you'll see something like oh, the web server can't see your file? Try chmod 777. That might fix it. What will what do you think that chmod 777 might do? For everybody, yeah. So that's not really the best idea in the world. You can be a lot more specific. So U for user, G for group, O for other, plus to add, minus to remove, or equal to set them to exactly that, and RWX for read, write, execute. So I think we have some examples. Okay, we have them. So, so yeah, we're just going through this in a hurry, so that you will have seen it. So if we go back one slide.
So chmod will set these permissions. So that kind of sets it globally. Chown is change ownership. So this is how we can just only change the ownership of a file. This doesn't necessarily change the read, write, execute bits, but it'll let us change files from certain groups or certain users to others.
So if the group has execute, then one way that you can get a user to have execute is to make sure the file is owned by a group that that user is in. Make sense? More or less.
So then change group is a very similar thing. Just we only want to change group permissions rather than who owns them.
And then that cat R flag. That's something that you'll see a lot, either lowercase or capital R. Do you have a question up there? Either lowercase or capital R means recursively. That means don't just change this directory, but change everything that's in the directory as well. So you have to look in the man page. Every once in a while, it may mean something different. But typically, when you see an R, it's like, oh, that means recursive. That means do not only this, but all of it.
That is also a very dangerous thing. You want to be careful.
Recursive anything is usually a bad idea, whether in functions for programming or for any type of these operations, because you don't know what's under it.
Yeah.
There's a little bit more in depth about what the LS does. So types of files, we kind of have all of the ownership, all of the types, and then various modification information about it. This is a good one. Let's do this.
Oh, yeah, question?
Sorry, what was the H outlet?
Great way to look it up.
How would you find out?
Not found. So that brings up an interesting point, though. So we are using software, right? And software is versions. So it might be the case that a flag exists in a newer or older version of the software that we're using. So the man page is only going to reflect the version of software we currently have installed.
And like these slides were written on my laptop, but I have completely different versions of things because I'm running a different Linux distro than this laptop. Like that's in 2013.
So touch is a neat command. So all it does is makes an empty file. So you should try to touch a file and then change the ownership to chmod or chown it to something else, and then inspect further.
So real quick pop quiz. How much of this line do I actually need to type to make it happen? Just the touch food part, the dollar signs, notations, and everything after the pound is just a comment to remind us later what we did.
So we can try that with a very dangerous example. So what we're going to do is we're going to touch foo, and then we're going to remove all things in the root directory. So we very much hope that this comment works, because if this comment doesn't work, we're going to erase the entire operating system. Aha! We're still here. That's not a good way to test a command, whether it's a comment or not, just for reference.
So, yeah.
Live dangerously.
Is the comments show up in your dash history, and they show up in reverse search as well. So
this is a very usual thing that I will do. Song name, artist. Oh, hey, what was that song name? And then with Control R, I can reverse search. So I can leave notes for myself in my bash history. So because I'm in a command line so much, it's very, very convenient to do this. Or for instance, let's say I do ls-l, and then I do some like crazy long command, like for I in a range, I want to echo I. So we're going to pretend this does something. So what is this? This is just a loop. That's for a bunch of numbers. Oh, but I ran this command. I want to remember, so I can leave a note for myself. Previous command prints 1 through 20. So now, if I type the history command, it'll list all the commands that I've run. And now I can see this very, very handy comment that I left myself, previous command prints 1 through 20. So this is good annotation. Obviously, other people can't see it because it lives just for your user, but this is a great way to leave notes for yourself.
Comments are awesome. Be kind to your future self. Tell them what the heck you were thinking so they don't need to
Also, never run this. So this is, I kind of briefly said it, but so RM is remove file. -R in this case is recursive.
Yeah, and it's forcing. Even if it shouldn't be removed.
Do it
I
anyways.
don't care, do it anyways.
And then root is the base level, so it would remove all files on the system.
So anyways, back to the slides before we teach how to use everything.
All right, so we're gonna touch a file and then change the ownership to a user that is not you.
Okay, and then I'm gonna freeze this on one of the slides and then go back to our cheat sheet on the other slide. So if we can go back to the change mod. There we go. That might help.
Oh, nice.
Yep. Isn't it like technology?
You gotta teach people that. You gotta know that.
They need to know not to when someone tells them to on IRC. They need to also
Dude,
know
Alt
about
F4 speeds up your program.
It does.
Yeah.
It makes you done with it already, like at the
Yeah.
blink of an eye.
That reminds me of RuneScape. You want to trade? Now run over a finger.
So I have
Huh?
to go. Thank
Uh-huh.
you for having this.
Oh, thank you very much. You can come watch the videos later if you can.
Yeah, the slides are up.
Thanks for coming.
Still we haven't vagrant yet. You could just like vagrant.
Yeah, sure we could.
Destroy. Vagrant.
It's a lot on the inside.
So let's give them 5 breaks and show them the answers. Less than 5?
Okay.
Okay. I'm kind of concerned because IRC always takes longer than you think it will.
Almost. Oh, only 27.
Yeah.
All right.
Of course.
Let's bump through.
Let's. This is going surprisingly well. Completely unrehearsed. Oh yeah, editor, please edit that part out too.
I was like, I was helping somebody had like linear algebra. I was like, I love doing this. I know how to do these. I don't have to look up how to do these. Doing other people's homework is so much easier.
Oh man, I have numerical analysis at the moment. It's really, really sucky because I'm really slow at math. Like I can't even do algebra very reliably anymore. Because I've been making my computers do it for so long. And so it's kind of really horrible. So I might try and do it in a not when you're around. One something like really easy to explain.
Who's teaching?
Some grad student who's actually pretty good.
Oh yeah.
Yeah. I don't actually remember his name, but I can look it up.
All right, so we'll come back in 30 seconds.
Yep, 30 more seconds and we'll show you the answers. It's actually pretty fun. Easy stuff.
This would be a good job.
I feel like we look like lizards. Well, you more so, you got the beard.
That's the goal.
Yep, this kind of is my job. Now, the whole like travel to conferences and speak about cool stuff and do stuff in your free time. Such a good job.
Yeah.
Like
That would definitely be.
my goal is to like by the now just be doing open source stuff all the time and getting paid to talk at conferences.
We'll go really slow down.
Yeah.
And anything you can do remotely is exponentially better.
Bless you.
What? Absolutely. I
See,
can just dip out.
you can do it from like a coffee shop.
Oh, you're not going to do
Being
all that?
able to dip out kind of is
No, I'm
detrimental.
not doing it.
Oh, yeah.
Wasn't on. Just communications.
Oh, doing what?
You guys are
I
both doing
was
the same thing.
doing my internship probably extended.
Oh, yeah. Turns out with mine, it's really easy because I was doing a set of kind of discrete minion tasks. A lot. Okay, it's been more than 30 seconds. It's been like a minute. We're going to bring it back together and we're going to give you guys the answers to this because there's a lot of content that we want to get through and I want to make sure everybody gets onto IRC.
Do you want to unfreeze?
So if you pull up a terminal. So we what I get and have those of you who are helping interrupt what you're saying. We'll have some more time at the end, and we're going to give you the answers right now anyway. So first we're going to cut the file. The file's called foo. LS tech L, so we can see it. So foo has default permissions. User and group can read and write, other code can read. So we want to give everybody read, write, execute permissions on foo. What's one way that we can do that? Somebody shout it out.
I'm going to type exactly what you say, so don't make it bad. What?
777. Yep, and then, perfect.
So notice a neat thing was that foo used to be gray because it was just a normal file, and now it's green because that has the execute permission.
And then, what's another way we could have done it? Like cut bar, and then so make bar executable, readable, writable, and executable to everybody without using 777. And we go back to the slides that'll see like a cheat sheet.
Pseudo chown DevOps group.
Shown.
Did pseudo chown DevOps group.
Did you have a DevOps user?
So this will tell us we have created a DevOps user. So we could definitely try to create user. We could also do U plus RWX, G plus RWX, O plus RWX, which is a really verbose way of doing it, but those are often easier to remember than the optimal. So with that, let's keep going. We talked about those. We talked about those.
Package management. This is a good one. I cut out a bunch of this because I thought we wouldn't have time. We will have time, so that's cool. So we used yum to install a package. So yum is a package manager. We did that before, so we did yum sudo yum install man. So sudo escalated our privilege. Yum is the package management. Install is an operation for it. And then man was the target of the command. So what it does is, package management is the idea that I should be able to install software and the dependencies for that software very easily. So Windows and OS X have a really hard time with this. Windows called Chocolatey that does some kind of package management. But the problem is that, let's say I have all these libraries on my system. Each program needs a different set of libraries. But I just want to install this particular version of the program. So it has a set of dependencies, but I don't want to have to manually install all of the dependencies.
Hey, Panda, what's a dependency?
A dependency is something that precludes me from installing the software. It's a required part of the software to run. So maybe I'm trying to install a game and I need a particular set of graphics assets. It's a dependency of the game because the game can't run without those assets. So the package management allows me to install software and resolve those dependencies. So it'll automatically calculate and fetch which packages I need in order to run that software. This is very nice. It allows you to very trivially add and remove software from your system. So rather than having to go to the control panel and right-click and click uninstall and wait 20 minutes and do this for various pieces of software, I can yum remove XYZ packages. And this will automatically remove the packages from my system without me having to manually delete any files.
Another thing that package manager gives you is a search feature in some way. There are different package managers for different flavors of Linux because it's not something that's built into a kernel, it's something that lives in user space. So flavors of
We talked about
we talked about that.
I asked the same question.
Oh, we can let one of the students answer that. What is user space? Guys? Somebody just shouted out. Exactly.
As opposed to? As opposed to the kernel.
Well done. So you go out and find, hey, what's it actually called for that one package that, like, I know it has Python in the name, but what do I actually call it if I want that version of Python, that kind of thing.
There's a couple different ways the package managers work. There are different ones for different flavors of Linux, like Emily said. Yum is the one that's used for CentOS. apt is for Ubuntu and Ubuntu Debian and their derivatives. And they also have a corresponding piece of software. So that's kind of the umbrella software. And then you have a specific tool to add or remove specific packages. So the one command you will need to know is RPM or dpackage. This will allow you to install the Steam package, which I know you're all installing on your Linux laptops, so that you can play your games on Linux. So what this does is it's different. This is more akin to running your exe or the Mac equivalent for software. So if I do rpm-i-install, I can point that at a file and it'll install that file. The package managers yum and apt abstract that a little bit and give me a nice interface to search for packages that are officially approved by the operating system maintainers. These lists are very extensive, most of them are very up to date, and they apply security updates. So it's a very nice feature because it'll automatically push to you security updates and new versions of software. A lot of software on Windows will do this, like Chrome updates silently. It'll just constantly update its version against what Google's putting out. Like League of Legends and StarCraft, their clients, when you launch them, will grab the newest software and install it. On Linux, we have package managers to do this for us, and it makes a much more seamless way to approach the management of software. So that's for an operating system. There are also package managers for languages. So let's say I'm working with Python. Pip is a neat package manager. It allows me to specifically grab Python packages. This is neat because I can have a complete work environment for my development code, completely isolated from the rest of the system. So that means that I don't have to contaminate. I can have my local user privileges to install software locally, as opposed to installing it globally on the system. This is a neat feature because suppose I have XYZ users on my system, but each of them has different dependencies for different versions of Python. One of them is working with a really old code base that only works with 2.6. One of them is working on a modern code base with 2.7, and one of them is crazy and running Python 3. Each of these can install their own versions of Python in their own home directories, and they never have to interact with each other, causing versioning conflicts. Ruby, Perl, Haskell, and Node also have these.
They all have varying qualities of virtual environment type tool that says, hey, for just this one folder, I want to be using these particular versions, nowhere else in the system. Python has probably the best, most mature, easiest to use, but the rest of them kind of have attempts at that. We'll talk about those when we get into your particular languages.
And then there's also other package managers besides those. Portage is for Gentoo, Pacman for Arch, ZipZipper, Nix, Brew, and then Chocolatey for Windows. Yeah.
And then there's often like multiple package managers available, like, you know, you wrap Pacman for Arch in Yellow, but that's a whole other conversation if you want to talk about running Arch.
So the other way to install software is to install it from source. So whether you've done this or not, this is like a rite of passage for running Linux. So basically, before, what package managers do is mostly install binaries. So what that means is that somebody else compiles the software, they put it in a central repository.
No, what's compile mean?
So compiled versus source. So a compiled program, I guess it makes sense to talk about source first. So source code is literally the lines of code that you are writing. For most languages, or for it used to be for most languages, this needed to be compiled into a binary file, an executable. So Windows, it's .exe. We have binary files for
Windows. And binary turned it into the machine instructions that your computer actually runs. It's actually like a few levels of abstraction up from what actually runs on your CPU because everything has so many different layers in it. But basically, a binary, you can just hit go or execute it, and it'll just go.
This is nice now because we have very homogenized hardware. Every single laptop in here is an Intel processor. That's really rad. That means we only have to compile our software once.
There might be some endings. There might
Sure.
be a really old Mac.
And so the neat thing about this is I only have to build my software for one particular computing platform. This didn't used to be the case. We used to have to pass around source code and compile it for various hardware architectures. So PowerPC is one, ARM is another, MIPS is another. There used to be all these various CPU architectures. Now, since everything's homogenized, we can use things like package managers and only distribute the binaries. But binaries are slow, or not slow, but they might be versions behind what the most modern code base is. We can go and download the most recent version of the code base, and we can compile it ourselves. So we can get bleeding edge software because we live on the edge. and we want to run very unstable versions of our favorite web browsers.
Or let's say that I have some really weird desktop, I need to apply a special patch to make it talk to my graphics card. So I'm going to have to download the source. You have to untar the source. Tar is a compression format, kind of like a zip file under Windows. It goes from, like, if I tell you, I have a file that's got 1,000 zeros and then 1,000 ones. That was a lot faster than saying 0, 0, 0, 0, 0, 0, 0, 0. That's basically how compression works. But tar makes it smaller. Tar, with its unzipping indentation, makes it bigger again once it's on your computer, so you can take it with it. And then you make whatever changes to the source you need to make. That's one of the more common reasons that you would actually be compiling something in the first place. And then it'll give you a, in this case, a configure script to customize.
Yeah, so particularly in this example, what the configure is doing, so remember / is going to run a file in the local directory. And then -- prefix. So again, this is a word that we're passing as a flag, not an individual character. And then equals, so this flag is now set to $home, which is the environment variable for your home directory.
In this case, you do literally type $, capital H, capital O, capital M, capital D, because it's an environment variable.
And then /programs. So what this is going to do is, rather than replacing the version of grep, which is a searching software, on the system, we just want to install this newer version to our home directory. That way only we have to use it. We don't have to force the other users on the system to do it. So it configures everything. Make sure you have all the dependencies for the libraries that you're on your system. This will not take care of those for you. You will need to manually resolve those. Make will compile the software with whatever compiler is required. This could be GHC or GCC.
About half an hour left, so let's not
Okay.
go into too much detail.
And then make install, it just drops it wherever you told it to.
Make is a magical utility that automates the compilation process for you and turns it from source into a binary that you can run.
I think IRC now.
Yeah, let's go through what's here. Okay, so you can do your hands-on stuff later. Yeah, okay, it's time for IRC. So, Internet Relay Chat is, how many slides? I've got about 10 slides on it. It's a very, very old protocol. It came out, the original RFC for it, which is a request for comment, which is actually the definition of the protocol. We'll talk about those later. Came out in May of 1993, so it may be older than some people in the room. It's at the heart of it just a chat program. It works anywhere you've got a terminal you can run IRC from. This is really advantageous if you're on an ancient machine, or if you've broken your ability to display GUI programs in any of the myriad ways you can do that on a Linux system. We are going to encourage you to get onto IRC because there's a network called Freenode, which pretty much every free and open source software project has a channel in to talk to one another, including the Linux Users Group, the Open Source Lab. There's a channel for Bootcamp, and so forth. The people that you want to talk to and learn from and get mentorship from are there. And did you know that Oregon State ran one of the first 2 IRC servers on the net? Just fun fact.
One of the first 2. One of the first 3.
Okay, one of the first 3, something like that. So basically, in this diagram, could we open the diagram in a new tab? Bigger. IRC happens on a thing called a network. The network is composed of a bunch of different servers. You've got a bunch of people who run a program that's called an IRC client that connects to a server on the network. There are also, you can have bots, which are automated clients on the network, like you'll meet Cantor when you join the love channel. Bots are just a script that sees a given input and gives you a given output. They can give a lot of stuff. There are some official services on Freenode and many networks, such as NICServe, that allow you to register your identity, keep other people from using your name. And as you see from all these little smiley faces connected, there's a whole bunch of people. You can connect to one server, and then since they're all on the same network, this lets you talk to somebody over here too. You can have multiple connections from one client. There's no real restriction on that. You can connect to multiple networks from one client. This guy can be on 2 different networks. So if we go back to the slide, please. Next one. So just to get you guys set up, we'll actually come back to these commands later. But basically, there's a couple of different ways of doing it. Conversations happen in channels. A channel name will start with a # or octaport, just like a comment in Bash would. and then it'll be the name of the topic that people are there to talk about. And once you have connected to a network, you can join into a channel on that network. And so you can be in a bunch of different channels. Every time you start and stop your client, you leave or join the channel. If you stop your client, then you can't see what's being said while you're gone. It's pretty good to see what's said while you're gone because somebody might have a question to ask you while you're away from your computer and you get back and you answer later. Somebody might have questions that you ask and you don't want to miss having that answered. So I'm going to show you how to set up IRC and what's called a persistent client. That means that we're going to have you SSH to a shell host. I'm going to recommend, if you're an OSU student, shell.onid.oregonstate.edu, and there's a huge guide for this on the website. And the username will be your ONID username. So you can do this using Tucky. You can do this using SSH if you're on Windows or Linux. I can't talk. I've said too many words today. So SSH if you're on Linux, SSH if you're on Mac, Tucky if you're on Windows. SSH to shell.onid.oregonstate.edu if you're a student. And then we're going to use this awesome utility called Screen. Screen has a bunch of different features built into it. The feature we care about is it gives us a named session, and then we can disconnect from that session. If our connection to Shell drops, like let's say we power off our laptop and then power it back on again, the things running in the screen will still be there. If you just ran a command on a regular shell session and then you disconnect it, that command will terminate. But Screen makes it so that it's always there in the background for you. The command that you're only going to run once because it creates a new screen for you is screen-S IRC. That's the screen session name is IRC. And then there are different clients available. URC and WeChat are the big command line clients. I'm personally an URC user. WeChat's a bit more modern, and a lot of people here use it. So basically, either one.
WeChat's better.
It is.
It's 2 versus 2. It's a draw.
WeChat has a bunch more features. It's a matter of personal taste. You can try both. And then once you've started that section, then that's going to be your client. You're never going to make a new screen unless the old screen died somehow. And then you're going to, as I'll show you in the next slide, which is not quite yet though, you're going to connect to the network, and then you're going to set your nickname, and then you're going to join the channel. And then this will always be here for you, running on Shell until they reboot Shell or you kill it. So you don't need to do this screen big S IRC again. You can just SSH back up there, and then to get that into your screen, it's going to be -DR IRC. And that should not be capitalized. That's a typo. It's case sensitive, so lowercase IRC. But D is, if it was connected anywhere else, disconnect. R is now reconnect to the one of this name. You can also find that in man screen, the man page. So we can keep going. So there's my picture of networks again. When you say /connect and then the name of a network, that causes your client to go talk to one of the servers. They have a little handshake that they do. It makes sure that your nickname is available. And then your connection. You're not in any channels yet, so you can't talk to other people unless you direct message them. We'll talk about getting into channels in a minute. First, a note about nicknames. So everybody has a handle that they go by on IRC. Starting on Freenode, so per network, you can only have one person per name. Like you can't have two people named John. You can have John A and John B or something, but the protocol depends on every nickname being unique. So this means you're going to have to find a nickname that's available. The good news is, if a given nickname is available on Freenode, it's probably available on those smaller networks. So when you choose your name now, you're kind of choosing what you're going to be called forever. Not really forever, just kind of forever. You can change your nickname.
Awesome guy is a cool nickname. You should pick that one. Most
no,
awesome
I
dude.
think
That's a
most
good
awesome
one.
dude still has it written to his account. So it turns out when you pick a nickname in middle school, you're still stuck with it out as you go into the professional world. So pick something based on your real name if you want to. Like mine's E. Dunham, because my name's Emily Dunham. So one word of warning is your nickname is going to be your face and your clothing style and that first impression that you make on people that you meet on the internet. So if you nick to, let's say, oh my God, it's a girl on the internet, and then people are like, oh my God, it's a girl on the internet, you kind of, what reaction were you expecting to get? So err on the side of professional and vague and just pronounceable is kind of nice. If you have special characters in your nick, it's assumed you couldn't get the nickname you actually wanted. If you have a bunch of numbers, then you kind of look like a bot. Do it all lowercase, don't put caps in your nickname.
Should we freeze the slides and then start helping, or?
Nicknames that are all caps kind of make you look like a bot. And once you've found a nickname that you can nick to and you don't get an error message saying it's in use or it's taken, then you're going to message nickserve. Note that there is no E on the end of nickserve, despite how it's pronounced. And then register, you're going to pick a password. Do not use a valuable password for this because people will occasionally accidentally see the password on your screen. Just some throwaway password.
Is there a way to make it so that password?
Yeah, stars show up when you type your password into a channel. Don't believe anyone who tells you that.
Yeah, I think that's what we
So is there a way?
There might be a way in Earthsea. There's probably a Perl script for it.
We chat defaults to stars whenever you do like mix or register a password. It should start out, but don't trust that.
Moral of the story, don't use a password that you've used anywhere else or bad things will happen to you. And then an email address. Using an email address is very important because if you ever forget your password, it will allow the Freenode staff to send you a password reset email. So once you've registered your nickname, then if something funny happens on the network and you come unauthenticated to that account, then you go message nickserve, identify, and then your password again. And nickserve is like, oh, I know you. That's the same password you gave me before. You're cool, and lets you be identified. There are some channels that you can't get into without having a registered nick that you're identified to because that cuts down on trolls and spam and stuff. Let's look at the next slide about joining channels so that people will know what to do once they've got set up. And then we can go back and we can do hands-on help with getting onto Freenode. So there are commands in your client. In general, if you type it into your client and it starts with a slash, it's a command to your client. The only exception to this is /me, space, and then an action. That'll show up in the chat. But something like a whois, a list, a topic, a name, won't show up to other people in the chat. So once you're connected to Freenode, you have a nickname. Join into the OSU Live channel and join into the DevOps Bootcamp channel. So some useful commands. The list command will tell you all of the channels on a network. Do not run the list command on Freenode. Freenode has way too many channels. It will crash your client. It will be bad. You'll flood out and get disconnected from the network. On a smaller IRC network, and you're just like, where are people talking, then it's fine. /topic will tell you what in the topic of the channel. Whenever you join a project's channel, whenever you're new to a project, read the topic, read whatever's linked to the topic before you start saying anything. You will occasionally hear on the internet the adage, work more. That's a good thing to do. Don't, I'll get into advocates in a couple more slides before we this first hands on. And /names tells you who all is in a channel. So you can take actions with me, like I said. If you want to tell someone a command, then you can preface it with /say. And then you're not going to run that command yourself. Like, if you want to tell someone how to leave a channel, /say space /quit. We'll put the word /quit into a channel. Just plain /quit will tell your client. Or give you a little, if you really want to do that message. So, yeah, useful tricks. Tab complete works on nicknames. This will cause you to spell people's nicknames correctly and not bend them. By default, it will highlight when your nickname starts a line. There are settings that you can make to highlight on certain words. So like if you're involved with the event and you want to highlight every time someone says the name of that project in a bigger channel, you can configure your client to do that. Some people's names will start with plus sign. Those are not part of the name. You will look like a noob if you type those in the channel. They just tell you the person's status in the channel. An @ sign means you're an operator. That means they can kick you if you annoy them. A plus sign means that they're voiced. That's just kind of a symbol of authority, like all of the officers of the LUD in the LUD channel wear them. Logging. It's safe to assume on IRC that anything you say is probably being logged somewhere, so don't say anything that you wouldn't say in a recorded meeting. If you want to keep your own logs so that you can search back through them for answers to questions and stuff, set logger log on is the client command. Chanserve and Nixserve. Chanserve tells you things about channels and helps you manage them. Nixserve helps you manage your nicknames and find out about other people's nicknames. Temper's a bot. Temper's one person. Temper will occasionally talk to you if you say certain things. Don't worry about it. Is there another slide after that?
No, I think we should just go to this.
Cool. You're saying there's not a slide? Or?
There is.
There's an etiquette slide. There's how not to annoy everyone. That's really important. The etiquette slide is how to make a decent first impression, how to not get everybody filing away in your head and their heads as, oh my gosh, that person's so annoying. So when you join into a channel, wait for like 15 minutes to see if it's busy, see if they're having a conversation, so that you can jump into the conversation at a good time. People who just join in and instantly say something, it's just like, oh wow, you don't know what you're doing. Don't ask to ask. I have a question. It's like, okay, that's nice. Now we have to like figure out your question. Or does anybody here know about Linux? No, you have to lure people out with hasty information because it's really unpleasant to go, I know about Linux, and then they ask a question that you don't know the answer to. And to avoid that, just ask your question. Read the topic. As I said in the previous talk, show that you were helping. Mention what you've tried to solve your own problem first, and this will cause people to respect you. Use the topic command. It won't spam everybody else. If you have code to share with someone or a long error message, there's this wonderful site called Pastebin. Pastebin.com, pastebin.osu.osl.org, any of these. Sometimes there's a preferred Pastebin for a channel, and that will be linked to the topic. If it's more than one line, sometimes it's even just one line, pastebin it and then drop the link to the pastebin. Don't paste code to the channel or everyone hate you. And as I said, choose your nickname kind of carefully. And if you do these things, come into the bootcamp channel, talk to people, make friends. You can make a whole bunch of friends and mentors on IRC. You can find jobs through the friendships that you make there, and it's a wonderful place. So let's get you on to IRC.
You want to freeze one of the screens, I think?
You have 15 minutes. So how many of you are not OSU students? Anybody? Okay, few people up there. We can talk about things with you individually. Those of you who are OSU students.
I can just put it up on the screen.
Yeah. Those of you who are OSU students, you will want channel.odit.org to take my teachings.
No, they were recommending
So what are you doing?
It doesn't matter.
Okay, yeah, and so then we watch the website and then we'll put our schedule there. Yeah, I can do 2 if you want. You have a. on fancy have a business card.
Yeah.
Just send me an email and you can just come by and I'll work with you. Yeah. Cool. Yeah, no problem. Yeah. Cool.
Yeah, it's not a stage, just put their username at the, for shall not open. Also, turns out, like, developers, now there's no We did.
So sometimes we'll say, so you can ask much hey, how do I change my name? And someone will say, oh,
So really close. I know.
Even though I said there's still one project.
So, yeah, you can also do this from the, so right now,
you already
what was that you're doing? So this is the shell. But what I'm saying is, this is not. So this is a security ID. So if you already know it, you know whether it's wrong or not. So well, that's good. Yeah. So then you're okay, so do you have a new where it actually
I don't know how to use that. So yeah, I only know how to use the chat. You can ask someone else.
And then logging those photos, log in, and then you just follow the instructions. So now you can do a screen walk, then the higher one, and then you can go over to the left side to do the chat. We chat is
yeah, they'll be different.
very bashful.
I'm trying to help you receive it.
Because right now,
Oh, what channel? So there's
Okay, so you guys want we can just install IRSSI and then we run it. So let's go back.
So it's kind of
and then you can like ask a question. So that we can then we can so if you just like stay here for like containing a buffer
that's why
yeah. So shell that is it requires your housekeeping, your passwords.
Yeah. So this is specifically the slot.
So we're gonna try again. I think might be mad at you because I tried again because it probably has a security thing that seems like a lot of sorry.
So do you remember the password?
It's just not. So anything in brackets like that, that you it's just another fancy word.
So you can't just password the right. So I tried password middle. Reset.
Well, we find out.
Or you do all of them in a
Yeah, so
There's also a lot to take a notes about a computer class. Oh my God.
I didn't see what you did, so I don't know. I don't know.
But like here,
Like either whatever command you want to change. So I would ask you to check out again. I could still do.
yeah, basically.
And then you slap it.
Oh, you're gonna run this one. Oh, okay. So see if you can see it run this one. It's good here. So there's three.
One word.
DR is just you're on a machine. So it's a whole portion.
I like it.
Yeah, so that means it's a active. That means it's still running in the background. Or just the other thing. And when it's active, you
So it looks like.
okay. So you should do yum install and dash Yes. And it's gonna tell us, yeah, sorry, you should have had an image do that by default. But, yeah, normally you have to do that by default. There you go. And then you know the after your action. Alright, so if you have to say after back to where you were. Also, I'm gonna tell you something.
Okay.
So yeah,
Shell.open is
it might also be nice to if you want to basically slash it, it will actually be if you want to basically use slash so you want to have it always.
So now that's DRC is what that.
Yeah. So if you don't use the boundary that you want to be able to create several things. So what are you trying to do? You just like want to look for now and come back there. So if you want to do that, you can like see and then you get back by doing and then you use that to get back.
What's the thing that's also
And that yeah, I did this cube.
So that was a command I submitted. So it's not going to be on the machine. Yeah.
Oh, okay. So if you want to go back to without our stage using control A and go
I can't remember how to set it. But you can set up shortcuts. So you don't have to. So, because you know, right now you have two.
And that really has to be, you do hire. There you go. So that's still the same program running. Because you're still in all the same channels. I want to write that down.
You can also use set up. That's pretty much
Oh, you're trying to talk here.
So,
I actually what's software. My translation. Okay,
I'll show you where that was.
something that's more on yes, there's always some application called
Oh, yeah.
Okay. Is that number? The 184. But the number right there.
Okay, brief interruption. It is break time. If you still want help, then thank you. Then go out there. If you're done, then cut out. And if you want to go get some food and come back and get help, that's cool too. We will reconvene at 3 p.m. Is it?
Thursday,
There is, yeah, we will reconvene at 3 p.m. in that other room because we have some DevOps people from Nike here to talk about what they do. So yeah, come back in here before 3 if you need more help. Yeah, good, pick it up.
It should put stars.
他这边有主管。
You can leave your stuff in here. We'll be back here after the Nike thing. If you want things like.
Like Avisa.
And also, it's just that ultimately,